So, you guys doing okay? At least it's Friday, so we'll have a weekend. So that's a good thing. So let me remind you of what we did before, like in the Wednesday. So we were doing this one. Okay, we have some like a ketone looks like this. We try to do reduction over here. Okay. So can you guys try this one real quick? So we can do this together. So we have sodium borohydride. There's a bit of a acidic condition here, and we're gonna try to reduce this compound here. Okay. So this is a compound that we're gonna reduce. See what happens here. This is what we did on Wednesday. It's 1 minute. About 1 minute we'll do this. So the reduction will happen to this one. Okay, 10 seconds. Reduction. All right, so here's the thing. So we have a sodium borohydride here. So technically it's just this one. So when it had this one here, this part will actually give us the hydride on here. Okay, so we're gonna have this one. Just a quick review. So we have that is donated to this carbon, the electrophile carbon here, and then what happens to this one? So this is gone now; it's neutral, and this is going to be make a bond here that make this the one of pair of electron in here will push up to the oxygen. So this will be gone, and there will be one more lone pair, negative charge. Okay, so and basically they're gonna pair up like this, but later they pick up the protons from here, which is so then you can have after this you can have lone pair here again. Okay. This one, we'll grab this one with one of the lone pair here. So eventually we're going to have this one. Okay. So this is what we did on Wednesday. Okay. So let me show you another one. Okay. All right. So if we have this compound over here, we're also gonna do the reduction on this one, but at this time there's another alternative way to do this. So we're gonna do with the lithium aluminum hydride, and then also we're gonna have a bit of a safe condition over here. So basically the mechanism is very similar to what we just did here. So this is also looks like this. Okay. So then what they do is they try to give us the hydride over here. Then this will be pushed again. Okay, push. So there will be hydrogen bound to this carbon here, and this will become negatively charged because they have one more lone pair on it over here. Okay. So initially they pair with the positive charge lithium cation here, and then they actually make a bond to one of this. So that goes to, let me see. So lithium goes away, okay? And then there's just two lone pair, but this one over here. now there's a ionic bond here, but this is now is neutral here. But later, this one will be used to breaking this bond. So oxygen will still take the process of these two electrons to one of the protons in here. Okay, you saw that already here before. And then they're going to this one. Okay, and they break apart. So lithium and the aluminum salt will be just leaving because it will breaking a lot, but they're gonna use for making graphene this one. So you have a hydroxy group here as well. So it's also another reduction here. So it's just pretty much the same, right? So if you use a sodium borohydride, if you use a lithium aluminum hydride, we'll do the same. So here's the reason why we're using this alternative way, even though they do the same job here. The thing is the lithium aluminum hydride is more reactive than sodium borohydride. Okay, so means that this is a bit more dangerous to deal in the experiment because it's more reactive. So more reactive means it's dangerous because it's going to react with a lot of things now. So if you're going to have other compounds or goes into biological system, it causes a lot of the reaction means of the trouble. So this is the reason why sometimes instead of the sodium borohydride, we have to use this one for certain case. This is the case we have either carboxylic acid or ester. Okay, so I'll show you this one. So if we have this one, or if you have this type of thing, only you can use this one instead of the sodium borohydride. So any other regular compounds, you can use either sodium borohydride or lithium aluminum hydride. It's okay. Either will work okay. But since this is more reactive than this one, these are very slow in reduction. So this is why for those two, you need to have a stronger reagent here, so it can happen. Makes sense, right? It happened in the preceding reaction. So in this case, what happens to this one is they actually try to reduce this one here. So let's try to do this one first. So this is pretty much the same, but they will do this twice. Okay, so they do hydride coming from here. Right, so when they just go, this will go to here. Okay, so then once again they make another push on here. So this will be gone, and there will be another lone pair here. It's a negative charge. So once again, it was initially paired with the lithium cation, but it grabs the this one. Okay, so then they'll make this one and this one now paired with the sodium is negative charge now. But here now instead of grabbing the protons, they're actually going back to the original form. So when this done over here, right? And now this is going back to the carbonyl group form again. So this will leave and become this. Okay, and then that here that pushes this one. Okay, so they will leave. Okay, they will leave. Does it make sense? Okay, and then you just do. So what's this one now? The regular carbonyl group compound, right? And you just do this one more time. Hydride shift again from here. So there will be two. not 1, 2, come here. They goes up to the negative charge, pair with the lithium initially, but they bond to the aluminum hydride, and now they attach that bond to grab another hydrogen here, another hydrogen here. So this will be this. So you're doing this twice. But the first step was try to detach your hydroxy group here in the carboxyl group, and you can make this the oxygen in the previous in the carbonyl group with the hydrogen. So now this will become your hydroxy group with the alcohol. Does it make sense? Okay. So yeah, just did it twice. Did it twice. So this is the product. Okay. So if you have this one, so one trick you can do here is this one. So you have this one, right? So if you have a stronger the reducing agent over here, you try to remove this one, and hydrogen, hydrogen, hydrogen. That's all you need to know. Okay. So if you have some carboxylic group which is slow in the reduction, that's why you need to have a stronger reducing agent. So only thing you have to do is remove the double bond here, add a hydrogen, and remove this one, hydrogen, hydrogen. And that's it. Okay. So if you know this trick, it's really easy. Does it make sense? Okay. Okay. So maybe you can try this one for me, real quick. So in this case, if you use the sodium borohydride, it won't be perfect. It will be really slow reaction. You still do this, but I would prefer to use this one. So on the exam, you need to choose this one over the sodium borohydride if it's a carboxylic acid. And also we're gonna do the ester one, but it's pretty much the same mechanism. Okay, about 1 minute, we'll just. Okay, so there's a double bond, right? There's the hydroxy group in the carboxy group will leave and hydrogen, hydrogen, hydrogen. Okay, so I'll show you the here. So I'm gonna do is this one and this one. Okay, so this hydrogen came from here, and these two are coming from here, right? Because there'll be two. So these two are from here. One is from here. So this is the correct. Makes sense, right? Okay. Okay. Perfect. So let me move on. So it's pretty much the same for the ester. So you have this one instead of this one over here. Okay, so it's pretty much the same. So if you have a hydride coming in, and then this will be this one. Okay, and then this will push. So negative charge will be stay here now. So this will be gone. Okay, and then same lithium, and later aluminum hydride, and this one. Okay, and then you're gonna use this one to make the original carbonyl group again. So it'll be gone. So then it's here. That makes this one push. Okay, here. Okay, so this will become OR minus, because this is the one gets the pair of electron here. So this will be gone. So this is now we have a once again regular compound with the carbonyl groups, and just do another hydride attack from this one, and then this will push negative lithium, aluminum hydride, and now they're going to use that one to grab hydrogen. Okay, so then this is okay. So another thing that you just need to know, because it's happening in the acidic condition, this one will later catch the proton. They become this another alcohol there. This is only difference, but the mechanism-wise, it's very similar. Okay? It's very similar. Either ester or the carboxyl group, carboxylic acid compound is just very same mechanism. Okay. So let's try to the example here. Let's try to do. So if you have this one, okay, this one, you can try to estimate the product over there. Okay? Don't worry about it. Just try, and we'll do this together in 1 or 2 minutes. So now instead of the carboxylic acid, we have a ester group here. We just need to do pretty much the same job here, and it will see. Okay. About 1 or 2 minutes. About 1 minute, 30 seconds. Okay, 10 seconds. Okay, so yeah, it's pretty simple, right? So only thing you have to do is try to remove the double bond here and detach that groups over there, and just put 2 hydrogen here. Okay. So these 2 are coming from here, this one coming from here. That's it. So this is it. Makes sense, right? Oh, and then you have this one, right? We'll grab this one. So this will become what? Methanol. So this is another product you expect from it. But technically, just the same mechanism we tried for the carboxylic acid. You want to try one more, or can I move on? Just one more. Okay, just do one more. Okay, let's do one more. So, but this one. Okay, this one. Let's try this one. Another 1 or 2 minutes. About 1 minute. Okay, so same, right? So we try to remove this one here. We're gonna add 2 from here, and we're gonna remove the double bond, and we're gonna add hydrogen. Okay. So that's pretty much it. Just another thing, that when you detach this one, which is grab the proton here once again, so this will become ethanol. Okay. Ethanol, right? So, makes sense, right? Great, so let's move on. You guys did great. All right, so the next part is the Grignard reactions that we kind of did in OGO 1 and the last week. So if you have this type of form, R, magnesium, and any halogen here, with the acidic condition here. And then you have maybe some carbonic group somewhere. Okay. What you can do is try to we're gonna have, if you look at this one over here, because this is metal, when they detach to each other apart, this will be slightly negative, slightly positive. So this will take the a pair of electron to attack here. Okay? So then this one will go up to there. Okay? So this will become this. Okay? Because we have one more lone pair there, donated from the pi electrons here in double bond. So this double bond is now gone. And then later, what it really does is just, for meanwhile, they just pair up with this positive charge, the magnesium halogen. But later, they just grab one of the protons from the hydronium, so they can actually form the hydroxy group there. Okay. So this promotes. Okay. So let's do one problem actually here. So if you have this one. Oh. Okay. Okay. And try to have this one over here. Okay. So we have this one. But they will detach as this is negative, positive over here, right? And the pair of electron will attack some over there, and then they'll push this one. So this will be gone, negatively charged with a 3 lone pair now, not 2 anymore. And then they're gonna, so momentarily they're gonna pair with this the positive charged magnesium, bromomagnesium, but eventually they use that one of the lone pair to grab the protons over there in hydronium. So will become, let's say, like this. So any R group or in this form will be attached on the carbon in the carbonic groups, and that the oxygen will grab the additional proton, breaking their double bonding carbonic groups. So that's the outcome. Makes sense, right? So it's almost the same, I think, but a bit of a different region. So let's give you one example here. Maybe can you try this one? Okay. This one. I'll give you about one or 2 minutes. And we'll do this together. About 1 minute. Okay, 10 seconds. So so I'm gonna add this one here, and then I'm gonna remove the double bond and just single bond here. And I'll just, that's it. Yeah. So this is the trick. So you have the double bond, the single bond here, and the carbonic groups. It will grab the protons, and this R group will attach to the carbon in the previous carbonic groups. That's pretty much it. Makes sense, right? I think it's also similar. So let's do one more. This one. And this one. Yes. Okay, about 1 minute. Okay, 10 seconds. Okay, so you have this R group here will be attached to here, okay? Because this is carbon in the carbonyl groups, and I'm gonna just make the single bond here, and this will grab hydrogen. That's it. Okay, so this will become. Yeah. Makes sense, right? I think it's okay to move on. Okay. All right, so let's do a little bit of a tricky one now. Okay? Not too much, but let's try to do a bit. So if we have the ester group, so we have looks like this. In this case, you need to have two, like we did for the lithium aluminum hydride. So what happens here is, once again, it's pretty much the same. They're coming in, okay? They're coming in here. So they push this one over here, so this will be gone. So now has one more lone pair, once again, will be negatively charged. So this part here will pair up just for a while, okay? Okay, so like a, like some ionic bond, like kind of interaction there. And then they actually eventually use one of the lone pair to make the carbonyl group again. So this will be gone now, and they can no longer interact there. So this will be gone, so there will be carbonyl group, and that makes this push over there. So this will be gone. Okay, so at the moment they become what? This one, because you had this group attached there, but this left. Okay? So this left, right? And then you're just gonna have a what? Another one comes in here, push down, and grab this one. Okay? So that's the once they have this one, and they're going to grab this one. So eventually, this one. So the thing is, whatever your R group here will be attached twice, instead of this ether group like in the ester group, we just leave. Instead of that, we have the same R in here that's twice, and this will grab the hydrogen here. It's a bit tricky, but just almost same. Okay, so let's try the problem here. Okay. All right, so let's try. This one, okay. Let's try to do this. So 1 or 2 minutes again. We'll do this. 1 minute. About 10 seconds. Counting time too fast. Okay. All right. So here's the trick. So what I'm gonna do is I'm going to remove this one. Okay. And then I'm gonna add two methyl groups here, and I'm gonna remove the one on the double bond, so it'll be single bond. I'll put hydrogen. That's it. Makes sense, right? So just remove that one, give two, not one, because it's a ester group, so it's not regular one, and then just give a hydrogen here, so it can be alcohol compound. Can I move on? Yeah, perfect. All right, so looks good so far. So there's kind of a special one. Here is the carboxylic group. So if you have this one, okay, this one, what happens to this one is you're not going to add any R groups in here. So when they break apart, this one will actually grab this one. Not here. They're not gonna attach here, but grab this one. So when they come apart, okay, they grab this one. Oops, actually, it looks like this one, right? So this goes to them. Okay. So if that happens, it will become negative charge because now I have one more lone pair there. So this is 3, and this will become methane. So now I'm grabbing this one, okay. And then they're just gonna make some ionic salt with this one, okay. And plus methane. That's it, okay. So technically, the form is if you have any R group here with the carboxylic group, they'll become the OH, the compound, so it'll be with the negative charge, and with the negative magnesium ion salt plus this one. So this is the form. So whatever the R, just pair with the hydrogen, and then this negative charge one will pair with this cation. So and this just stop there. Okay, makes sense, right? Yeah, okay, perfect. So let's try to do just one practice and I'll move on. Okay, so let's try to do this one. Oh, yeah, I'll give you just the same thing again. So you have to expect the 2, right? I think you already understood everything, but just in case, one more. Okay, about I think like 30 seconds. I think this is quite easy. So. Okay. Yeah. So 10 seconds. 10 seconds. All right. So what I'm gonna do is I'm gonna do this one. Okay. So we'll have a methane here, and then this one will be like this. That's it. All right, so let me move on. So here's just something you may see on the exam. So for example, if you have this one. Let's do this one. Over here. Okay. So you have this one over here. What you can do is the oh, so I'll just give you this product here, and maybe you can think of any way to make the product here. So for example, for me, what you can do is try to copy this one over here. Okay. And then try to copy the same carbon over here. But the way you have a hydroxy group, just switch it to the carbonyl group. Okay. And then you just need to have one of this. Okay. So maybe I'll choose out of these two. I'm gonna choose this one. Okay. So then to make this one, what you need to do is adding this one and making reduced over here, right? So what you can do is what? Then you have a product there. Makes sense, right? So if I give you the products, you'll be able to know, oh, if I have this compounds with this one, we can have make this one. So there's two other way you can do the same. Can you guys maybe try? I show you the one. There's two other way you can do it. Maybe you can try. So there's two other way to the same compounds, same products. So this will take like 2 or 3 minutes. Okay, so let's do 2 or 3 minutes. Okay, about 1 minute. We'll do this together. Okay, about 30 seconds. Okay, so here's the thing. So the trick is very simple actually. So I choose this one here, but you can do another one with this one, and then you only need to do this one. And it will make the same one because I chose this one, and you're just adding this one instead. So it's the same. You can also add this one as well. So you can have looks like this. Okay, so all right, so makes sense, right? You just have to switch each one of them. That's pretty much. Can you maybe try one more? Just one more. Okay. You can try to. Can you try to make this one? This one. There's several ways to do so. Either way is okay. You only need to know how to make this one with the Grignard reaction. Okay.
Okay, maybe 1 minute.
All right, so we can have, so the trick is you can just copy this one here, right? So it'll be over here. So you can do, this one over here. So there's another trick you can do is like this one. Okay, and this way you can actually have this one. Okay, because so in this case you're gonna add 2-methyl twice. Remember this one, right? The ester, the will have it twice. So this will be gone, 1, 2. See? This is only adding 1, so that's okay too. But this is another trick you can do with this one. Whenever you have the same R groups on the alcohol, so you can do the same with the ester group. Okay. All right, so I will just stop here today.